Any questions from that problem set? Very good. Very good. Okay, so let's go back and finish up the notes on the other parts. So we're going to fill in the independence and homogeneity sections. So, for our hypotheses, for independence, HO is going to be there is no relationship between the two variables. Because remember, it's one population, two variables. So this is that's going to be our HO. There's no relationship. HA is going to be there is a relationship. And we just fill in the context of the problem. For homogeneity, or HO, is going to be the distribution of choices is the same among the populations, because remember here we're comparing two different populations to each other to say, are they the same? And of course, that would be your in context. The populations would be explained in context of the problem that you're working on. Thank you. So degrees of freedom. For independence and homogeneity, it's going to be the number of rows minus 1 times the number of columns minus 1. So take away one row, one column, and then multiply those together. Thank you, Liz. Conditions stay exactly the same. Same conditions for all three of these. So that's kind of nice. You don't have to change the conditions. For the expected counts, this one is slightly different formula. We'll do the row total times the column total. Divided by the table total. And you'll do that for each of the boxes in the table. calculator, we'll put our observed. Since we're dealing with a table of values, we put these into a matrix. So we'll put matrix A will be our observed. Our expected will go into matrix B. And then you'll choose C, chi-square test. So instead of choosing GOF test, it's just chi-square test. Now, the nice thing is, if you put your observed in A, and then you do chi-square test, it will calculate the expected for you. You just have to make sure you write it on your paper. So once you put your observed in A, you do chi-square test, go back into your matrix. In matrix B, your expected counts will already be there. Just write them on your paper. And we'll look at that when we do an example. And then in step 5 and 6, exactly the same. Okay, so let's look at an example. So first thing we want to do is look at our hypotheses. So here we want to know, is there sufficient evidence that the response is dependent on gender? So is there a relationship between the response and gender? That's what they're asking us for. Okay? So we see we have a table of values. So we have two options. It can either be independence or homogeneity. Any idea which one we have here? Independence. Good job. Good job. Yay. So our HO is there is no relationship between the gender and the response. HA would be there is a relationship. So to get our degrees of freedom, we just take out one row and one column. And we count how many cells are left. So we have 4 that are still there. That's our degrees of freedom, is 4. Two minus 1, and then 5 minus 1. If you want to look at it in the formula, the rows minus 1, columns minus 1. 4. Then we want to find an expected count. We want to find an expected count for female somewhat disagreed. So female somewhat disagreed is right here. So I'm going to go all the way over and I'm going to find the row total. And then I'm going to add these down here and find the column total. And then I'm going to go over here and find the table total. Well, we know we had a random sample of 200 students, so our table total should be 200. So we just need to add up across and add up going down. So going down is 40. Going across 110. Okay. So to get the expected value, 110 times 40. So these two multiplied together, divided by the total for the whole table. So I get an expected value of 22. Are we good with that part? Okay, so to get to the matrix, some of you may have not had to deal with it in a while. So you'll see right here is matrix, right below the math button. So you'll do second matrix, and then we'll go over to edit. And this one, we'll do a 2 by 5. And then you should have something displayed that looks in the same shape as what you have up here. And so you'll just enter each of these values in the location here that matches. So once we have all of that entered, we're going to quit out of that. So second quit. And then you're going to go into your stack test, and you're going to get that chi-square test. So letter C for chi-square. Or observe to say, yours should look like this unless you've changed it at some point. So A, B, calculate. Now we haven't put anything in B, but the calculator will do that for you. You do not have to do that. And then calculate. So there's our chi-square. There's our p-value. There's our degrees of freedom. Then this next part, you'll go back to your matrix, so second matrix. When you go to edit and down to B, those are all your expected counts. So those just need to be written on your paper at some point. So expected counts equals, and then write that matrix. Okay, so then we're just going to make a decision based on the p-value. So our p-value is 0.06. So that's greater than an alpha level of 0.05. So we would what? Not reject. Good. We do not have evidence. And then we just write HA. That gives you an example. The other one, the test for homogeneity, The mechanics of it are exactly the same. The only thing that changes is your hypotheses. Everything else is done the exact same way as what we just did for this one. So on your problem set, you have an example of some of these with tables, so work through them before Thursday so you get some practice with it. And then we'll spend a little time Thursday going back through and doing more examples of these.